Okay, last one. Okay, draw quantitative bar graphs and explain why you drew the bar sizes that you did. Okay, a child drops a ball from rest. It rebounds against the ground and raises back up, but not quite to the original height. The total energy of the ball is 15 joules, and 30% of the energy turns to thermal during the collision with the ground. Okay, all right, so here goes the kid on the chair, okay, and the ball. All right, kid on the chair. Okay, and I'm getting a consistent background here because I don't think the kid's going to move. Okay, I do want to include the collision, okay, and it raises back up. So you can do it anyway. You could do initial, like middle here, final at the ground, okay, or you could do, initial, middle, final. Like your middle could be when it's at the ground, and then it could bounce back up. Okay, so it doesn't really matter. I'm going to go ahead and make my middle where it's colliding with the ground. Okay, and then my final, I'm going to make on the way back up, just to make it more interesting so that I can see some kinetic energy. Okay, otherwise nothing's going to be moving. Okay, all right, so initially, all right, we've got 15 joules total. So let me go ahead and do this in threes. Nope. Why can I not add? I've been making so many videos, I can't anymore. Okay, 6 joules, 9 joules, 12 joules, 15 joules. Okay, so I'm going to go ahead and just go by threes on all of this. 0, 3, 6, 9, 12, 15. 0, 3, 6, 9, 12, 15. Okay, all right. Okay, so let's see. Okay, so initially the child drops a ball from rest. Okay, it rebounds against the ground. The total energy of the ball is 15 and some amount is thermal. Okay, all right, so initially it's from rest. There's nothing compressing or stretching right now. So that means all of the energy has to be EG. Okay, it's above the ground, so no whooshies. Okay, so EG, max height, EK, 0, no whooshies, not moving. EE, 0, no compression. Okay, and balls aren't going to stretch. They're really going to compress, right? So I'm only going to worry about compression. Okay, all right, now in this middle position, okay, by the time it gets here, it's on the ground, so nothing. Okay, it's also not moving anymore, right? Because it is not quite, it's stopped, as it's on the ground. Okay, so that means all the energy is going to have to be stored elastically, but it says also some is lost. Okay, so again, 15, okay, times 30%, okay, is going to be 4.5 joules. All right, so that means right in the middle here somewhere, 4.5 is going to be the thermal. Okay, and then the rest would be 10.5, I guess, right? 10.5 is going to be stored as elastic. Okay, so 10.5 plus 4.5 equals 15 joules. Okay, so EG, 0 on ground. EK, 0, not moving, no whooshies. EE, max, compressed. Okay, and E, thermal, wasted due to collision. Okay, now it doesn't say whether or not to include air resistance. Okay, so depending on what your teacher has said, you may or may not do it, and you may or may decide not to do it. Okay, so this 4.5, right, is during the collision. So if you were looking at it as other energy was sort of wasted on the way down, that number might be a little bit bigger. Okay, and then it would need to get even bigger in the last picture. All right, if you're really only going to look at the collision with the ground and then decide you're just kind of going to ignore the rest of the air resistance stuff, okay, then you can just keep this ETH at 4.5, okay, because it's already been wasted and no more is wasted after that. But you still have to track the amount that was wasted over here, okay? All right, so I'm going to go ahead and make it on the way to the top, okay? So it's not compressed anymore. It's going to have some EG. Let's maybe give it, I don't know, 6. Oh, wow, look, that makes a square. That's really nice. Okay, that was nice. Okay, let's give that 6. Okay, and 4.5, and then I would need another 10.5. I would need another 4.5, right? 4.5 for kinetic. Okay, 4.5 and 6, right? Because that'd be 6, 4.5, and 4.5 is 9, plus 6 is 15. Okay, and that's fine. And I have some amount of whooshies, right? Because it doesn't matter how big the whooshies are exactly, because there's nothing to compare it to, okay? But if it is less whooshies, it needs to have less EK, more whooshies, more EK, if there's a comparison. Okay, but on this one, there's really not. Okay, so EG, it's part way up above the ground. EK, it's moving, right? So I can see the whooshies. EE, no. E thermal, same, carried over from that loss, right? That's why it's not going to go as high. It's going to eventually get to the highest, okay? If you drew this to its new highest point, right, then the kinetic would be 0, okay? If you chose that as your final point, that's fine, okay? But then you'd have no EK at all anywhere, which is fine because, I mean, you know, you're just picking 3 snapshots, okay? All right, done.